Welcome to the VisiView feedback microscopy application video. You may have already seen the potential of the custom acquisition editor to easily set up complex experiments. We've seen how to launch a macro that runs during the experiment and how to analyze cells directly in a single workflow. Taking the idea of customization further, we inevitably ask about conditional imaging, also called smart imaging or feedback microscopy. This means that the imaging parameters are changed at runtime based on certain conditions. Let me illustrate the potential with an example. Imagine we have a slide with thousands of different plant pollen, and we want to find and observe only one specific pollen, for example the pine pollen, which we also call Mickey Mouse pollen. I will show you how I used feedback microscopy to transfer the whole workload of finding the Mickey Mice and acquiring a Z-stack of all of them to VisiView. So let's delete the acquisition tree and start from scratch. The first step in our experiment is to scan the specimen. We drag and drop a scan slide node to the first position after start. For testing purposes, we check the position and focus of our sample and add a small acquisition region of 3 × 3 tiles. The second step is to search and find the Mickey Mouse pollen. To do this, we use the assay node and select a ready-to-use object analysis settings file that runs an AI model trained to recognize Mickey Mouse pollen. As we want to access the analysis data later, it is important to set the output to memory only. The next step would be a predefined macro that converts the Mickey Mouse pollen positions into stage positions. But before we add this, we need to create the rest of our experiment. So we need a stage list, and we will run a Z-stack for each Mickey Mouse pollen. So we add the Z node to the stage list loop and set the Z range to 30 microns. Now we add our macro, which will retrieve the object positions from the saved assay and convert them to stage positions for the next stage position list node. Let's shorten the name a bit. In the end, I thought it would be nice to display the pollen as a maximum projection and crop the center as the pollen are quite small. A positive side effect is that the amount of data to store is reduced to a minimum. Finally, we need to test what we have created so far. We press Sequence to start the custom experiment. First, the sample is scanned. I can already see some Mickey Mouse pollen, which are now added to the stage list. Now the Z-stacks of the Mickey Mouse pollen are acquired. And finally cropped and maximum projected to give us our result image stack. So we have found all 6 Mickey Mouse pollen in this area. I hope you enjoyed watching this video and that it motivates you to make your imaging smarter with VisiView.